Good day everyone. Today we'll be discussing about the concept of normal distribution and z-scores. Okay, when we say normal distribution, it is a distribution or a graph that tells the location and the probability of a score to occur with respect to all the values occurring randomly. Okay, the concept of normal distribution happens or used whenever you want to, example, conduct a study on the age of students or the scores of the students in a national achievement test. Since it involves a large number of population or large number of subjects, we can have we can graph a what we call a normal distribution from that example. So if you pick a score, basically a score will have a probability, and in every probability we can also relate, or we can also determine the corresponding percentile of that score. And then to determine the percentile or the probability of a score to occur, we need to convert that score to a z-score. So basically, a z-score is simply a numerical instrument used to determine the relationship of a row score to the mean. Now, if we're dealing with mean based on population and population standard deviation, so we will be using this one to convert our row score into a z-score. However, if we have a small amount or a small number of subjects, or we're dealing with samples, we'll be using this formula. Okay, let us now examine first, before we'll convert the row scores into z-scores, let us first examine the graph of a normal distribution. So this one is an example of the graph of a normal distribution. So we have here, at the middle of the distribution lies the z-score, which is 0, and this 0 in this location also, it tells us that the mean is on the middle side and the middle part of the distribution. In the median and the mode are equal, or lies in the middle of the distribution. The normal distribution also tells us that most of the scores are clustered near the mean. So that is why it is one of the characteristics of the normal distribution. And then the values to the right are those values that are greater than the mean. And if a z-score lie on the negative side, meaning those numbers or row scores that were converted to z-scores are below our mean or at the middle. So basically, if you have larger scores, so there is a possibility that your score lies on the right side. But if your scores are lower than the mean, so there is also a possibility that your score lies on the left side of the normal distribution. Okay, so let us now convert the z-score of a row score. Okay, suppose you have a population mean which is 80, and then we have the standard deviation, population standard deviation is 4, and the row score is 85. So basically, example, if in a test the mean population of this score is 80 and the standard deviation is 4, then let us predict if what is the probability of occurring x equals 85, or the score of 85. So since the given is a population mean and a population standard deviation, so we will be using this formula. So we have z equals x minus the mu or population mean all over standard deviation equals x is 85, so we will have 85 minus the population mean is 80 and the standard deviation is 4. So we'll just subtract these two numbers. 85 minus 80 is simply 5 all over copy 4. Then after subtracting, we need to divide these two numbers to get the z-score. So we have 1.25. Okay, in other words, so the score, which is 85, lies in the z 1.25. Now, what does it tell us? So it tells us that the score, which is 85, is, if we'll go back to the normal curve, so if our 85 is in the middle, since this it's or the 80 is the middle, since this is the mean, and 85 is 1.25 somewhere here, it means to say that our score is above the mean, or at the right side of the normal distribution. So the question now is, how are we going to determine the probability of z? Z equals 1.25. Now to do this, we need to use the z table that we have right here. So z table for the normal curve. So we have, since the z-score is 1.25, so we will pick, or we will look for 1.25. So we will first look for this 1, 2, 1.2, and also the 5. If we draw a horizontal line of 1.2 and also a vertical line for 0.025, the intersection of the line, that line, will be the corresponding probability for 1.25. So in other words, the probability of z equals 1.25 is 0.8944. Or if we express this one in percent, this will become 89.44. 44%. Now, what does this also tell us? If we're going to talk about the concept of percentile. So basically, if your score is 85 and the mean or the population mean of all the scores is 80 and the standard deviation is 4, the score of 85 is or lies at 89.44% or 89 percentile, meaning to say, if you are a student who scored 85, it means to say that you are, or your score is greater than or higher than the 89.44% of the population. So that's it. So now let's take a look at example number 2. Example in number 2, we have number 2 our population mean is 80. Then we also have the standard deviation is 4, but our x or the row score is 70. So let us determine the probability. So we will just simply again write z equals x, the x is 70, minus 80, which is the mean, and divide it by 4. So subtract these two numbers, it will give us negative 10, and then copy 4. So that will be negative 10 divided by 4 is to negative 2.5. Okay, in other words, our score, which is 70, lies on the left side of the distribution, since it gives us a z-score of negative 2.5. So somewhere here at the middle of negative 3 and negative 2. Now what is now the probability of z equals negative 2.5? So we will now again use the z table. So this time we will locate negative 2.5 and 0, since we are involving, well, we have only one decimal place right here. So we will just simply locate the value of negative 2.5, the intersection of negative 2.5 and the 0, 0. So we have 0.0062. So the probability now is 0.0062, or in percent this will become 0.62%. Okay, that's it. That's how we're going to solve or determine the z-score and the percentile, or the probability of the occurrence of that score with respect to the population mean and the population standard deviation. So comment down below if you want to know more about topics related to statistics, and then like, subscribe, and hit the bell button to get notified with the future uploads. Thank you.